talking about proving triangles similar. So if you remember from yesterday when we were talking about similar polygons, we had two requirements that we needed to follow. Those two requirements were that number one, we had all angles congruent, and number two was that we had all sides proportional. That was how we proved polygons were similar. Now, if you remember from yesterday, that takes quite a long time to set up those proportions for every single side to make sure that every angle is congruent. So instead of doing that every time, we have a couple postulates and theorems that are going to help us save some time because they're a little bit of a shortcut. So we will eventually talk about indirect measurement. I don't know why that's on there today, but the first thing we're going to talk about is postulate 7.1. I'm going to put this in a box. Postulate 7.1 is our angle-angle similarity postulate. You're going to see these acronyms that look very, very similar to what we did with congruent triangles. Remember AA, we didn't have an AA, but AA, the next one is going to be SAS, the next one is going to be SSS. They're familiar. However, things are a little bit different. With AA, we only need two parts. The two parts that we need are two pairs of congruent angles. If we have two pairs of congruent angles, we can say these two triangles are similar by a similarity with the little squiggly on the end. The next one is SAS. If you remember about SAS when we talked about congruence, remember that the order of those pieces matters. SAS has an angle that is sandwiched in between two sides. So we can see that in the diagram here. Here's my angle in the middle of two sides. So very, very similar to what we were doing with congruent triangles. However, there is one main difference. Yes, we have one pair of congruent angles. The sides, however, are not congruent. That's the difference between similarity and congruence. We're not trying to say that the sides are congruent. They might not necessarily be, but we do have to prove that I have two pairs of proportional sides. And again, those sides are sandwiching in that angle in between them. Otherwise, it's not SAS. And we have SAS, similarity. Questions on that one? The last one we're going to see is SSS, similarity. It's exactly what you think it is. It is three sides, so this just helps us skip the angles part altogether. If I know that all three pairs of sides are proportional, then I know that my triangles are similar. By SSS similarity. Okay, any questions? That's a little shortcut. So let's first start off with two examples of angle-angle similarity. We're just going to see why they are similar and then write the similarity statement. So I have two right angles. Those are a pair of congruent angles for me. And then I also have two pairs of 58-degree angles. Therefore, two pairs of angles that are congruent gives me that these two triangles, and here's where we have to make sure that we line things up. AXM is similar, with a little squiggly, to triangle BXK by angle-angle similarity. That's literally it. Angle-angle is nice and easy. Okay. Number 2, explain why the triangles are similar and write the similarity statement. I see one pair of angles here that are congruent. Do I have a second pair? Caitlin. Perfect. By what? Lovely. So then these two triangles, again, are similar. We would say triangle RSW is similar to triangle, make sure we're lining things up, VSB by angle-angle. Any questions on that? Very straightforward. Moving on. I have two examples using SSS. When we're using SSS, again, remember, we're not going to have things that are congruent. We're going to have things that are proportional. So you should be setting up an extended proportion for these side lengths. There is not always going to be angle measures. Okay, this one, we don't have angle measures. So you have to be able to look at this picture and tell what things line up. Obviously, I'm not going to put the 9s and the 8s together. Those aren't the same pieces. I'm going to put the 6 with the 8 because those are those short legs. And another 6 with the 8. And then another, I'll switch colors, the 9 goes with the 12. That's my extended proportion. Now I make sure that all three of these fractions reduce to the same number. What do these three fractions reduce to? Nobody. Allegra, Thalia. Thank you. So that's my scale factor. So whenever I reduce my side lengths, they reduce to the same number. They reduce to that scale factor, aka similarity ratio. So I will literally just be able to say A, B, C is similar to triangle E, F, G by SSS similarity. That's all I'm doing here. Questions on that? Okay, they love an overlapping triangles diagram. The way we tackle these is we're going to draw them out separately so that we can see the individual pieces. So I'm going to take my small triangle, which is AP, not B, APJ, with side lengths 1, 2, and 3. And then I'm going to take my large triangle, which is triangle ABC. I know this bottom side length is 21. When we're doing this, make sure that you are adding up these entire side lengths. I don't want to see that AB is 12. I want to make sure that we are adding 12 plus 2 to get 14 here. I want to make sure that we're adding 1 plus 6 to get 7 over here. Everybody cool with that part? Now again, when I start setting up my extended proportion, I shouldn't be lining up the largest piece in one triangle to the smallest piece in the other triangle. I'm going to line up the two smallest pieces together. The 1 goes with the 7. The next one, the middle pieces. 2 goes with the 14. And then the largest pieces together, 3 goes with the 21. I make sure that these reduce to the same number, which they all should. They all should reduce to 1/7, which is my scale factor. And then I can say triangle APJ is similar to triangle ABC by side. Similarity. Any questions on that? Amazing. Next section is SAS. So now I'm making sure that my angle is sandwiched in the middle of those two sides. If it's not being sandwiched in the middle of the sides, we cannot use SAS. So let's take a look at letter A. I have my right angles. Those are my congruent angles. And then I need to make sure that the two sides that sandwich that angle are proportional. So I'm going to line up. Again, shortest pieces together. Longer pieces together. Do they reduce to the same thing? They should both reduce to 3/4. So we can say triangle PRQ, similar to triangle ZYX by side angle side. Am I moving too fast for you? I feel like we're cooking on those ones. Okay? The overlapping triangles are where they get tricky. So I have triangle NMP is my little one. Side lengths 2 and 3. And I have triangle, big triangle, NQR. Side lengths, don't forget to add your side lengths together. 12 and 18 are my side lengths. If I just look at those two triangles right there, do I have enough to prove them by side angle side? I see two sides. I'm missing an angle. I'm going to tell you right now, we have enough information to do this by side, angle, side. How do I get that angle that I need? Dahlia. N is the vertex. N is congruent to itself. They share this angle in common. They do this a lot with overlapping triangles where they share an angle in common. It's not going to be marked. You just have to know that, hey, reflexive property means these two angles are the exact same angle. So I do have enough to prove this using side, angle, side. Let's just double check that my sides are proportional. 2 goes with 12 and 3 goes with 18. They both are going to reduce to 1/6. So NMP is similar to NQR by side, angle, side. Questions on that? Okay, we're going to put it all together. We're going to make sure that we can look at a triangle diagram and identify what my reason is going to be. Keep in mind, we didn't do any today, but you will see parallel lines with transversals come back, where you're going to have to do like corresponding angles or something like that in your homework today. Don't freak out when you see that. Okay, let's look at number 1. What do I have here? How can we prove that these two are similar? I don't have any side lengths in here, right? So it's got to be angle, angle, or it's nothing. Do I have 2 pairs of angles, Caitlin? Yeah. What are they? Perfect. I have my 2 right angles, and I have my reflexive angle E, which is the same in both triangles. So I can say, yes, these 2 triangles are similar. I'm going to line up my pieces. A, B, E goes with D, C, E. They are similar by angle, angle. And then, do I have enough information to write a scale factor? The scale factor comes from the sides. So when we prove something using angle, angle, and there's no side lengths available, we can just say that it's not enough information. That doesn't mean that they're not similar. It just means I don't have enough information to write a scale factor. And that's okay. Last one. I'm going to try to do this without drawing out my 2 triangles separately, because I know sometimes we get bored of that. What do I want to use here? AA, SSS, or SAS? Casper? Okay, let's try to use SAS. What's the angle that they share? Go ahead, if you know it. Yeah, they share this angle at H. Okay, that's my reflexive angle. Now I'm going to compare the sides. I'm going to take, for the small triangle, 2.7 corresponds to what side length in the large triangle? What's the side length of that large triangle? Caitlin? Perfect. We're adding those 2 pieces together. We have to get 4.5. I do not want to see any 1.8s. 1.8 only talks about that little sliver on the bottom. On the other side, same deal. I have the 1.2 as the small side of my, of the other side of my triangle, my small triangle. What's the corresponding side on the other big triangle? 2. Okay, we did this yesterday a little bit. How do I get rid of those decimals? How do I simplify to get rid of them, Caitlin? Yes, multiply by 10 to make it a little bit easier for yourself to simplify there. 12 over 20 and 27 over 45 are much easier to simplify, in my opinion. I believe we can divide, what does this get me? 3/5? Is that true? So scale factor 3/5. Triangles similar, G, H, J, and F, H, K by side, angle, side, similarity. Beautiful. Oh, yes. Any questions?